Hello everyone, welcome to My Math Teacher. In this video, I am going to solve question number 3, 4 and 5 from the exercise 6.2. This is for class 10 students from NCERT syllabus. Chapter is triangles. We will be using basic proportionality theorem to solve all the 3 problems. Now, what is basic proportionality theorem? We know basic proportionality theorem is in a triangle when we draw a parallel line which is parallel to a side like this, like BC. So we can say that AD divided by DB is equal to AE divided by AC. So this is what we'll be applying in solving all the sums. So now let us start. Given here is question number 3 is in the figure if LM is parallel to CB, LM is parallel to CB and LN is parallel to CD, you have to prove AM divided by AB is equal to AN by AD. So now let us start from the first one. Here given is LM is parallel to CB. So this is LM which is parallel to CB. We are going to consider this triangle, that is ABC. In triangle ABC by basic proportionality theorem, that is BPT. In the triangle ABC by basic proportionality theorem, we can say that AM divided by MB is equal to AL divided by LC. Let us consider this as equation number 1. Now after completing this, let us consider the next one. LN parallel to CD. Here LN is parallel to CD. Now consider this triangle ACD. Okay. Now we can say AN divided by ND is equal to AL divided by LC. Given is LN is parallel to CD. Now in triangle ADC by basic proportionality theorem, we can say that AN divided by ND is equal to AL divided by LC. This is considered as equation number. So you can see both the LHS are same, AL by LC the same here. So when the left hand side are equal, we can say right hand side both are equal. So we are going to equate 1 and 2. So what we get? We get that AM divided by MB is equal to this portion, that is AN divided by ND. Okay, this is what we will get. So after equating, we have got AM divided by MB which is equal to AN divided by ND. Now you can see the proof is AM divided by AB. So we have got the numerator as same. Both the sides numerator as same, whereas the denominator is different. Okay, so now we have to change the denominator. So in the denominator we have to bring AB here. So we can see from this line segment AB can be written as AM plus MB. So you can from figure AB is equal to AM plus MB. Now coming back to the equation AM by MB, I am writing the reciprocal. I'll explain why we are doing this step later. Okay, just write the reciprocal, that is MB divided by AM is equal to, when you are doing something on the left side, the same will be done on the right side also, that is ND divided by AN. Okay, now here we need to get AM plus MB. So for that we are going to add 1 on both sides. AM, we are going to add 1 here. The same we'll be doing on the right side as well. AN plus 1. Okay, so why we are adding 1 onto the both sides? Why? Because when you take the LCM here is AM. So you'll be writing MB plus 1 into AM is AM. Okay, now this is what we need to get AB. That's why we are adding 1 on both sides, which is equal to, the same way take the LCM as AN, the numerator is ND plus 1 into an is an. Okay. Now we know that MB plus AM, it is equal to AB. It is equal to AB divided by AM, which is equal to, from the figure we can say ND plus AN. When you add both the parts, we will get it as AD. So it is AD divided by AN. Okay. Whereas the proof, it has given us AM by AB, which is equal to AN by AD. So now just write the reciprocal, that is AM by AB, the same reciprocal, which is equal to AN by AD. Okay, this is what we have to prove. Hence proved. From this step, we have made some changes. So what we did first, we took the reciprocal. Why we are taking the reciprocal? What happens if you are not taking reciprocal? I'll explain here. So if we are writing AM by MB, which is equal to AN by ND. Okay, if you are not taking any reciprocal, simply if you are adding 1 on both sides, definitely you should add 1 on both sides. Why? Because then only you will get this form. Okay, so now take LCM, it will be MB AM plus MB. Okay, which is equal to ND is the LCM, AN plus 1 into ND is ND. Okay, AM plus MB is AB. You will get it by MB, which is equal to AN plus ND is equal to AD. That is AD by ND. This is what we have to prove, and this is what we have got. Now, when you are doing the reciprocal, you are getting AB and AB here. The same way you are getting AD and AD here. Whereas again, you will not get AM. Instead, you are getting MB. Here the same AN is not available. Instead, we are having ND. So this is the reason why we have taken reciprocal from this step. Okay. So you can understand now very clearly. So let us move on to the next question. Fourth question is, in figure, this is the given diagram. DE is parallel to AC and DF is parallel to AE. Prove that BF by FE is equal to BE by AC. First of all, let us consider this. DE is parallel to AC. Here, DE, this line, it is parallel to AC. Okay. We will consider this triangle ABC. By basic proportionality theorem, we can write BD divided by DA is equal to this one, BE divided by AC. Let us write BD divided by DA is equal to BE divided by AC. Let us consider this as equation number 1. Okay. Next, it is given as DF is parallel to AE. So consider this DF, this line is parallel to AE, this line. Okay. Now you can see this is from this triangle. So we can say the triangle here is ABE, because consider this as the line which is parallel to this. So we can write in triangle ABE by BPT. If this is the case, we can write BD divided by DA is equal to BF divided by FE. This is equation number 2. So if both the LHS are same, which means RHS, they are also same. So therefore, equating 1 and 2. So we get BE divided by EC is equal to BF divided by FE. Okay. So the same, LHS and RHS both are same here. So hence proved. Fifth question here is, this is the given diagram. DE is parallel to OQ. So we can see D to E, this line is parallel to OQ. Now which triangle we will be considering? That is POQ. DOQ. This is the triangle we need. Okay, we can say by basic proportionality theorem, we can write PE divided by EQ is equal to this PD divided by DO. The next given is DF is parallel to OR. This line segment DF is parallel to OR. Okay, now we can see the triangle is very clear, PRO. Now basic proportionality theorem, we can say PF divided by FR is equal to PD divided by DO. Both the equations have RHS as same. So from 1 and 2 we can say LHS both are same. Now here we have got, so when we are equating both the equation, we have got PE divided by EQ is equal to PF by FR. What we have to prove? EF is parallel to QR. Now PE divided by EQ. Now you can see here PE divided by EQ, which is equal to PF divided by FR. What is the meaning? From this we can understand that this line, so when they are both the sides are equal, we can understand that EF, this line is parallel to QR. So this is by converse of basic proportionality theorem. So what is converse? If a line is parallel to a side, we are saying PE by EQ is equal to PF by FR. Now we have got the proof. Okay, so from the proof we are saying EF is parallel to QR. That is called as converse. Okay, so therefore you can write by converse of basic proportionality theorem, EF is parallel to QR. Hence proved. I hope you must have understood all the three sums which I have solved in this video. See you in the next video. Until then, take care. Bye. Keep practicing.